Bismillahir Rahmanir Rahim. Welcome back, students. This is Hamza Noor, and in this video, I'm going to answer question number 2 of International A-Level Edexcel M1 January 2022 paper. It says that a particle P has mass km and a particle Q has mass mkg. And it says that the particles are moving towards each other in opposite directions along the same straight line when they collide directly. Immediately before the collision, P has speed 3u and Q has speed u meter per second. So as a result of the collision, what happens is that the direction of motion of each particle is reversed, okay, and the speed of each particle is halved. Part A says find the value of K, okay. So here we have two particles, P and Q. So I've drawn two circles over here, meaning two particles. So P has a mass of km kg, okay, and Q has a mass of mkg. And what's happening is that particles P and Q are moving towards each other in opposite directions, obviously. So P is moving towards Q and Q is moving towards P. So immediately before the collision, P has a speed of 3u meter per second and Q has a speed of u meter per second. Okay, so this is basically before the collision happens, before the impact. And after the collision, what happens is that direction of motion of each particle is reversed. So it means that P is going towards left and Q is going towards right. And since the speeds are halved, so what happens is that the speed of P becomes 3u over 2 meter per second and speed of Q becomes u over 2 meter per second. So in part A, we are asked to find the value of K. So what we are going to do here, we are going to use the law of conservation of momentum, which is that the total momentum before the impact is equals to total momentum after the impact. So total momentum before impact is equals to total momentum after the impact. So I'm just writing this formula for the sake of formality like this with words. You don't need to use these words exactly when you are solving this particular type of question in paper. All you need to do is just use the law of conservation of momentum and make an equation. Okay, so this is just for the sake of formality. So the total momentum before the impact is equals to the total momentum after the impact. And obviously here you need to assign a particular direction to be positive. So I'm taking right hand side direction to be positive. Otherwise, you can take the left hand side direction positive as well. Here I'm taking the right hand side direction as positive. So first I'm going to write the total momentum before the impact. And since I've taken the right hand side direction as positive, so this will be km multiplied by 3u plus m multiplied by minus u, and this whole thing will be equals to the total momentum after the impact. And since I've taken the right hand side direction as positive, so this will be km multiplied by minus 3u over 2 plus m multiplied by u over 2. As simple as that. So therefore we can say that 3kmu minus mu is equals to minus 3 over 2 multiplied by kmu plus mu over 2. So what we can do over here is we can take mu as common on both sides of the equation. So taking mu as common, multiply by 3k minus 1, and this whole thing will be equals to taking mu as common multiplied by minus 3k over 2 plus half. As simple as that. So mu and mu are cancelled out. So therefore we can say that 3k minus 1 is equals to minus 3k over 2 plus half. Okay, so we are going to solve this equation. 3k plus 3k over 2 is equals to half plus 1. So 3 plus 3 over 2, which means 4.5. So 4.5 k is equals to half plus 1 means 1.5. So therefore k is equals to 1.5 divided by 4.5, which means k is equals to 1 over 3. So the value of k is 1 over 3. And here we have solved part A. All right, so then we have part B. Part B says that find in terms of m and u the magnitude of the impulse exerted on Q in the collision. Okay, so I'm going to erase the working of part 1. And in part A, we actually found k is equals to 1 over 3. So I'm just going to write the answer over here of part A. K is equals to 1 over 3. And then we are going to solve part B. So in part B, we need to find the magnitude of the impulse exerted on Q in the collision. So when the two particles will collide with each other, so the force which is exerted on Q in this collision, it will be the force which is exerted on Q by P. So this is going to be the force of impulse, which will be acting towards right. So alternatively, what we can say is that we have an impulse over here as well. So this impulse is basically the force which is exerted on particle P by particle Q. So both impulses will have the same magnitude. So you can do it in both ways. So as you have already seen in part A, I've taken the right hand side direction to be positive. So I'm going to apply the same thing over here. Okay, so you can do it in alternative ways as well. So we need to find the impulse. So the formula for finding the impulse is that impulse is equals to change in momentum. Final momentum minus initial momentum. Okay. Final momentum minus initial momentum. So in this way, we are going to find the magnitude of the impulse, and our focus will be only on the particle Q over here. Okay, in this case, I mean the approach which I'm doing right now. All right. So impulse will be equals to, we are only seeing the momentum on the particle Q. So since I've taken the right hand side direction to be positive, so the final momentum will be m multiplied by u over 2, and then subtract initial momentum from it, and the initial momentum will be m multiplied by minus u. Okay, so the magnitude of the impulse will be mu over 2 plus mu, which means half plus 1, which is 3 over 2. So impulse will be equals to 3 over 2 multiplied by mu. This is basically the magnitude of the impulse exerted on Q in the collision. Alternatively, what we can do over here is that we can consider the particle P. We can find this impulse, it will have the same magnitude. And a usual practice is that in whichever direction the impulse is acting, you take that particular direction as positive. So in this alternative approach, what I can do is that take the left hand side direction as positive. Even if you take the right hand side direction as positive in this case, it's absolutely fine. No issue in that. Okay, so here I'm taking the left hand side direction as positive, and here we are going to use the answer of part A, which is k is equals to 1 over 3. So this is basically an alternative approach. So impulse is equals to final momentum minus initial momentum. Okay, so here our focus is completely on the particle P, and since in this particular approach I'm taking the left hand side direction is positive. Okay, so impulse would be equals to km multiplied by 3u over 2 minus km multiplied by minus 3u. And here we are going to use the answer of part A, which is k is equals to 1 over 3, and we are going to get the same magnitude of impulse. So impulse will be equals to 1 over 3 multiplied by m multiplied by 3u over 2 minus 1 over 3 into m into minus 3u. Here I don't have a space, so मैं लिख रहा हूँ थोड़ा नीचे. So impulse is equals to this 3 and this 3 is cancelled out. So therefore impulse is equals to mu over 2 plus mu, as this 3 and this 3 is cancelled out. Okay, so therefore impulse is equals to 3 over 2 multiplied by mu, same value of impulse. Okay, so you can do it in both ways. So this was question number 2 of this paper.